Hello, math humans. We're going to do 7.4a today. We're going to be talking about partial fraction decomposition. Our objectives are that we're going to manage partial fraction decompositions, which is often abbreviated PFD, and we're going to be doing that with both reducible and irreducible factors. So a little disclaimer before we get started, I manage these differently than your text. Because I manage these more from a calculus standpoint, meaning that I'm a little bit more quick and efficient. A partial fraction decomposition is a method of rewriting rational expressions as a sum of simpler rational expressions. For example, if I had a rational expression that was x plus 7 over x squared minus x minus 6, I might break that up into some separate fractions. We'll talk about how we find these in a little bit. And each one of these is called a partial fraction. So those are the partial fractions. And so it's a way of rewriting an original rational expression and breaking it down into something that has simpler components. I think the easiest way to do one of these is just to start with an example, and I will talk us through the steps. So for example 1, you're going to be given this problem right here. So x plus 7 over x squared minus x minus 6. Well, we can factor the denominator to be x minus 3 and x plus 2, which is always the first step. It's the first thing that you're going to do is factor the denominator. So now I can rewrite this. Note this is a linear factor, which means its degree is 1, and this is a linear factor. So I'm going to write this as a over x minus 3 and b over x plus 2. So the next thing that we're going to do is we're going to multiply both sides of the fraction by this lowest common denominator. And I'm a little bit lazy, and so I tend to write it down like this. It's helpful to write this down because I think it helps you to not make mistakes. So when we get to this point, we'll notice that if I have both of these right here, so I get an x plus 7 on the left-hand side, the a has the x minus 3, so it gets multiplied by x plus 2. And then the b has the x plus 2, so it would multiply by the x minus 3 because the other factors would cancel out. So now what we're going to do is I'm going to distribute. I'm going to leave the left-hand side alone, and I'm going to get ax plus 2a plus bx minus 3b. And I'm going to write a series of equations from this equation that we've written right here. So this is kind of our primary equation. For this particular partial fraction decomposition, I'm going to write a linear equation and I'm going to write a constant equation. So I have an ax. I tend to draw a line through it so I don't forget that I've already used it. And then I have a bx, and then that equals x, and that's this x from the original equation. Now I'm going to mark that out. Now I'm going to write the constant equation, and I'm going to have 2a minus 3b, and it is equal to 7. And really what I'm trying to solve for is I'm trying to solve for a and b. So I'm going to drop this into a matrix based on this information. So the first coefficient is 1, 1, and 1. My second coefficient is 2, negative 3, and 7. Okay, and then I'm going to solve this particular system with RREF. And so then I would do RREF. And just in the interest of time, I'm going to write the solution because we've done this several times now. And you're going to get a is equal to 2 and b is equal to a negative 1. Right? So you would do this math in your calculator, do RREF, and these would be the solutions. And notice then I go back and write these variables in the original, and so I'm going to write my PFD is equal to, a goes with this one, so there's 2 over x minus 3, and then I have a negative 1 over x plus 2. So if you multiplied, if you put these lowest common denominators together and multiplied, you would get back to the original function. Alrighty? Okay, a couple of things, we're going to do several examples because they get to be a little bit more entertaining. A couple of things to notice. The PFD that we just did was called reducible, R-E-D, meaning that we could factor and get linear factors. Irreducible might be something like x squared plus 9, because if you set it equal to 0, you would get x squared equals a negative 9, x is plus or minus 3i. Okay, it's irreducible if I get an imaginary number. So those are going to be our two basic types of factors, reducible and irreducible. Okay, if I have a reducible, then it's going to be an a and a b and a c for however many linear factors I have. For an irreducible, it's going to be ax plus b, and then the next one would be cx plus d, and if there was a third one, it would be ex plus f, etc., etc. So let's just walk through now, and we're going to do another example. I think that will be helpful. So the second example, our original fraction is 6x squared plus 1, and it's going to be divided by x squared times x minus 1 squared. Now this one is a little bit different than the one that we did previously in that I have factors that are squared, and anytime you have a factor raised to a power, you have to do it 1 degree at a time. So I would write a over x and then b over x squared. So these two take care of this guy. And then this is still just a linear factor, so I'm going to write c over x minus 1 and d over x minus 1 squared. Okay? The next step is to multiply both sides by that original denominator. So I'm going to multiply both sides by x squared times x minus 1 squared. The denominator always cancels on the left-hand side. So on the left-hand side, I get 6x squared plus 1. The a has one of these, so the a is going to be multiplied by an x minus 1 squared. The b is going to be multiplied. It has these two. It needs these two, x minus 1 squared. The c is going to get multiplied by x squared and 1 of those. And then the d is going to get multiplied by the x squared. So this is a much more complicated system than the one that we did before, but it's really still pretty straightforward. I'm going to write down below this and simplify these. This is x times x squared minus 2x plus 1. And so this is going to be x cubed minus 2x squared plus x, and that's going to be what's multiplied by a. This is going to be x squared minus 2x plus 1, and those guys are pretty easy. Oop, this one's going to be x cubed minus x squared. So we got that one, that one, that one. So now I'm going to rewrite it. So I'm going to have 6x squared plus 1. I'm going to leave that one there. The a is going to get multiplied by the x cubed minus an a times x squared plus an a times an x. Okay, and I'm just looking to make sure I don't screw up. And then I have a bx squared minus 2bx plus b plus cx cubed minus cx squared plus dx squared. Now, if you'll notice in this one, in the last problem, the example that we did, we had linear and constant. For this one, we're going to have cubic, and then we're going to have quadratic, and then we're going to have linear, and then we're going to have a constant. So we're going to write 4 equations this time. I always start with the highest degree, and notice that there is not a cubic term over there, so we'll just give it a 0. So I have an ax cubed, okay, so he goes away. There's no b cubed, so I'm going to put a 0bx cubed. and then I have plus a cx cubed 0dx cubed equals 0. And that's that guy right there. Okay? I'll write each different equation, and I used this one. All right, now we're going to do the quadratic. So I have a negative 2ax squared. We use that one. I have a bx squared. I use that one. And then I have a negative cx squared and a dx squared, and that's going to equal 6. Okay? There's my 6x squared. Now I'm going to do linear. I use those two. So now I have an ax, use that one, minus 2bx, use that one. There's no cx, and there's 0 dx, and it's going to equal 0. Alrighty, need another color. And now let's write our constant equation. There's not an a, and then there's a b, there's not a c, and there's not a d, and our constant is 1. Okay? Now the book would have you solve these equations, and I think that it just gets to be horribly tedious. And so we are, and in calculus, this is just a means to an end. This is only a tiny wee bit of a problem. For us, this is the problem. So my next step is I'm going to drop this into a matrix. So, and all I'm interested in are the coefficients, because I'm solving for the a's, the b's, and the c's. I just write these guys down to help me keep everything in the correct order. So in this one, I have 1, 0, 1, 0, 0. In this one, I get a negative 2, 1, negative 1, 1, 6. And then I have a 1, negative 2, 0, 0, 0. And this one, 0, 1, 0, 0, 1. All right. So now what I'm going to do, use my handy dandy grapher, because thankfully I have a handy dandy grapher. I'm going to edit A, and it is a 1, 2, 3, 4. So it's 4 by 1, 2, 3, 4, 5. Okay, and now I'm going to enter my data. 6, 1, negative 2, 3, 4, 1, 0, 0, 1. Super important that you check and make sure that you get everything in the right place. I have 1, negative 2, 1, 0, 0, 1, negative 2, 1, 1, negative 1, 0, 0, 0, this one's good, this one's good. And you got it. I'm going to do second REF because it's still in my grapher. If it wasn't, I could figure that out. And I hit enter. And then I'm going to record my data. So I have A is equal to 2, B is equal to 1, C is a negative 2, and D is equal to 7. So now what I'm going to do, can you still see it? There it is. Now I'm going to rewrite my original equation. So I'm going to say my partial fraction decomposition is equal to 2 over x plus 1 over x squared plus, I like to do it like this just because it helps my poor little pea brain, and then plus 7 over x minus 1 squared. Alrighty, and you can't see it, but that is my partial fraction decomposition. So it's really a pretty cool process. The book would have you do it completely differently, and you can choose to learn that method. I think this is easier. All right, we have one more example to do because this one's a wee bit different. So for example 3, this is our last example, by the way. I'm going to have you find the partial fraction decomposition, and I have x squared plus 4x plus 1 over x cubed minus x squared plus x minus 1. So this one is a little bit different because of the way the factors are going to turn out. So I'm going to start by factoring by grouping. These two have an x squared in common, and I get x minus 1. There's the 1, and then I have x minus 1. Now they have an x minus 1 in common, and I get x squared plus 1. This is a linear factor. This is one of those irreducible, because if I set x squared plus 1 equal to 0, I get x squared is a negative 1, x is plus or minus 1i. So this is irreducible, so that's going to change the way my PFD looks. So I'm going to write down x squared plus 4x plus 1, and then I'm going to write it in factored form, x squared plus 1. So the first one is just the same that we've done. It's a. This one is irreducible. I guess I forgot to write that guy down. This one is going to be bx plus c over x squared plus 1. So anytime you have a factor that is irreducible, this is going to be your numerator. And the process is exactly the same. So I'm going to multiply both sides of the equation by the original denominator. I'm going to get x squared plus 4x plus 1 on the left-hand side. The a has the x minus 1, so it needs the x squared plus 1. The bx plus c has the x squared plus 1. It just needs the x minus 1. So now I just need to do some math, and I'm going to get ax squared plus a, and then this is going to be plus bx squared minus bx plus cx minus c. And you always just want to be really careful when you do your math that you don't make silly sign mistakes, because a silly sign mistake is kind of the kiss of death. All right, so now I'm going to have a quadratic, a linear, and a constant. So I'm going to write ax squared plus bx squared. There's not a c squared term, so 0cx squared, and it equals 1x squared. So we did that guy. The next one is going to be my linear. I don't have an ax. I have a negative bx. I have a cx, and that's going to equal my 4x. And then, so use that guy, that guy. Now my constant, I have an a. I don't have a b. I have a negative c equals 1. So now I can just drop this into my matrix. Yay, matrices. So this is 1, 1, 0, 1, 0, negative 1, 1, 4, 1, 0, negative 1, 1. And in this one, I'm not going to do the RREF. I'm going to trust that you can do that because you're brilliant math humans. When you do, you get a is equal to 3, b is equal to a negative 2, and c is equal to 2. So now all I have to do is record my solution. I'm going to put the 3 over x minus 1, and then I'm going to have a negative 2 times x plus 2 over the x squared plus 1. And all I'm doing is taking the variables that I found and substituting back into the way that I set up my original PFD. All right, my dears, that is it for today. I will see you soon.